So, before we can do much of anything with algebra, use it to solve these logical problems that it's designed for, we have to have a basic understanding of how it works and how these symbols, this code, can be manipulated. It is worth always bearing in mind that anytime we have a letter, we are using that to code for a particular number. Now, a reminder, we might know what that number is, we might be finding out, we might never know. It doesn't really matter, but whenever we have any letter being used, it is code for a particular number. Which means that these letters have to behave in the way that numbers do, because they are just numbers. So when we're using a letter as a code, it could stand for any number, potentially. It could stand for a whole number, it could stand for a decimal, a fraction, a negative number. Any of these different types of numbers that we've worked with could be coded for with a letter. They also have to obey the basic rules of numbers. So we have to be able to take letters and do things like add, take, times and divide with them. We have to use powers and roots. All the BODMAS stuff still applies because they are, at their heart, just numbers being coded for with a particular letter. Now, one of the first ways that we can manipulate these algebra codes is we can do something called simplifying. Now, simplifying is effectively just writing things in as neat a way as possible. And to do that, we need a couple more bits of notation. If we look at these three expressions, they are expressions because they're just pieces of algebra not equal to anything. If we look at these three expressions, here we've got 2 lots of x, here we've got 3 lots of y, and here we've got 10 lots of r. Now x, y and r are particular numbers. So this 2 lots of x, 2 times x, would be 2 lots of the particular number that x is code for. 3 times y will be 3 lots of the particular number that y is code for, and 10 times r is 10 lots of the particular number that r is code for. Thing is, having these times signs in there is a little bit messy, because 2 lots of x, well, we could write that just as well without the times sign, really. So what we're going to do, the first bit of simplifying, is that we could just write that as 2x. We drop out the times sign and make sure that we've put the number first. The number always tends to come first, just because that's just the way that we set it out. It just looks a bit neater, it's a bit easier to think about. 2x is the same as 2 lots of x. 3 times y we could rewrite as 3y, and 10 times r as 10r. Why is that easier? Because if we wanted to, say, add these 3 things up for some reason, just as an example, writing it like this, we'd be writing 2 times x plus 3 times y plus 10 times r. And that's a little bit messy. Writing them with these pieces of notation, we'd instead be writing 2x plus 3y plus 10r. Which, yes, I admit, still looks a little bit messy because it's a lot of letters and numbers and it's a bit weird going on, but it is slightly easier to understand. It's certainly easier to read that this is 2 lots of x and 3 lots of y and 10 lots of r, and then those things added together, because we haven't got all these times signs in there that don't actually matter. So the key takeaway from this is this bit here, that whenever we have got numbers and letters being times together, we can just drop the times sign out. We know it's there, and sometimes it might be helpful to put it back in, just for our own understanding, but we can drop them out and we can write them in this simplified form. From this point on, we're going to do that every time. Now we can extend this idea a little bit as well, because it doesn't just apply if we have got numbers times letters, like the 3 times x being rewritten as 3x, for example. We can also use this idea if we've got 2 letters being times together. If we've got something like this, say, a times b, we can simply drop the times out and write that as a, b. A and b are 2 particular numbers that are being coded for, and we can simply write them next to each other. A times b is a, b. We can also, if we wish, write them as b, a. Remember that when we times things together, it doesn't matter what order we times them in. 2 times 3 and 3 times 2 give the same answers. We would tend to go alphabetical order here just because it looks a bit neater, a then b, but actually b then a is perfectly valid as well. The key thing, though, is that we can drop out the times and we can just write the 2 things next to each other. It actually doesn't even matter how many things we are timesing together. If we are just timesing things together all the way through, we can drop out all of the times signs and mush everything together. So 3 times x times y. X is a particular number, y is also a particular number. We're timesing those together, but also timesing them by 3. Remember, of course, we can do these in any order we like, but we can simply drop out the times signs and we can simplify that as 3xy, where really we know that is 3 times x times y. We know that the times signs are there. They are just hidden in there, and if we needed to put them back in for some reason, we could put them back in, but in terms of simplifying them and in terms of writing this in the neatest way possible, we can simply drop out the times signs and write that as 3xy. It's also worth pointing out 2 more things. If, for example, we have 0 times x, well, yes, we could write that as 0x. We could drop out the times, but surely if we have no lots of something, we can just write 0. Because 0 times anything will be 0. 0 lots of something is 0. Same kind of idea, if we have 1 times a particular letter, let's go with the x again, 1 times x would be 1x, but surely if we just have 1 lot of something, we could simply write x. Because how many lots of x are there? Well, just the 1, because we're not told that there are 2 or 3 or 4 or whatever. This, as an idea, a single letter on its own, is standard notation. We would tend not to bother putting the 1 in front of it. And certainly if we were to look at exam questions that had single letters on their own, whatever the letter happens to be, we would tend to just see the letter on its own without the number in front. It is not wrong, however, to write a 1 in front of it. It just is a bit redundant. It's a little bit pointless to put it down there. If you would prefer to put the number in front of the letter to remind yourself that it is a 1x, then you are more than welcome to do that. You don't need to, and it's neater to just write the letter on its own, so x or a or b or c or whatever, rather than 1x or 1a or 1b or 1c. But if you want to put the number in, that is absolutely fine. It might be that in certain questions it is helpful for you to put the number in front there. Right, let's have a little look at powers in terms of these things. It seems odd to skip onto powers when we've not really looked at the add, take, times and divide in that much detail. All will become clear shortly as to why we're looking at powers at this point though. If we think about, for example, this x times x, well, we know that when we have 2 letters that are being times together, we can simply drop out the times sign in the middle and write the letters next to each other. So technically we could write this as xx, but that seems a little bit pointless, because think about what is happening to this x here. X is a particular number, and we are timesing it by, well, itself. We don't know what the x is, but that doesn't matter. We're taking this number x, we are timesing it by itself. And if we times something by itself, what are we doing? We are, of course, squaring it. So we could simply write that this simplifies to x squared. That number x, whatever it happens to be, squared, timesed by itself. Similarly, if we had something like y times y times y, what are we doing to the y? Well, we're timesing it by itself and then timesing it by itself again. We are cubing it, y cubed. And if we had something like z times z times z times z, that's 1, 2, 3, 4. Z's being multiplied together, z to the power of 4. Now we can start to bring some of these ideas together and look at timesing things, simplifying through timesing. Because the key thing is that we can do these times questions in any order that we want. So a question could go, simplify. And this is actually the first of our algebra key words. We're talking about simplifying here, but this is one of these algebra keywords. Now, there are certain algebra words in questions that really tell you exactly what you need to do, and this is the first of them, simplify. And simplify means, effectively, drop out the times signs and write it in as neat a way as possible. But the idea is that we should collect together anything that we can collect together. For example, if the question wanted us to simplify 7 times x times x. Well, let's ignore the 7 times for a minute. This x times x, we know that we can simplify that as x squared. But that still leaves us with a 7 times in front. So we would be having now 7 times x squared. And surely we could just drop out the times there and write that as 7x squared. We've dropped out all the timeses. It just so happens that the x and the x have combined to make an x squared. And 7 times x squared means 7 lots of that x squared. 7 lots of that particular number that x is code for, squared. Something a little longer and messier now. Simplify 3 times 4 times x times y. So again, the idea with these is that we combine together anything that we can combine, and then we drop out any of the times signs that we can get rid of. Well, 3 times 4, we can actually combine that. We could do that. 3 times 4 is 12. We can also surely, once again, combine the x times the x as x squared. And what we're left with after we've done that is 12 times x squared times y. And surely those times signs don't need to be there. And we could just mush this all together and write this as 12 x squared y, where there is a times sign hidden between the 12 and the x squared, and there is a times sign hidden between the x squared and the y. It's just that we don't need to write them because we are simplifying. And simplify as a question word, a clue word in a question, tells us that we need to be doing this process. Now this is probably the most complicated of simplifying questions, something like this that actually does look very messy. 4xy times 7xyz. Well, what I'm going to suggest we do first of all is I'm going to suggest that actually we put the times signs back in, the ones that are there. And we could write this as 4 times x times y from the first bit times 7 times x times y times z from the second bit. 7xyz, 7xyz, 4xy, 4xy, and that times in the middle. Why is that a useful thing to do? Because this is just a string of a load of things times together. Now, if we have got things being times together, we can do them in whatever order we want. So why don't we shuffle the order of this around so that things that are similar can go next to each other? Why don't we drag the numbers to the front? Why don't we drag the 4 and the 7 to the front and write that as 4 times 7? And then why don't we have the x and the x, so times x times x. And then why don't we have the two y's times y times y? And then why don't we just have the times z on the end? This is all the same things. We've still got times all the way through. We've just dragged the numbers to the front, then the x's, then the y's, then the z's. X, then y, then z in alphabetical order just because it's a bit neater. Surely now at this point we can combine stuff. We can combine the 4 times 7 to be 28. We can combine the x times x into x squared. We can combine the y times y into y squared. And then we've just got the z on its own at the end. So we've got 28 times x squared times y squared times z, and those times signs we can drop out again, and we can just write this as 28 x squared y squared z. Right, so that covers us for simplifying with multiplying, and we've covered simplifying with powers as well, because there's that kind of overlap. Let's have a look at simplifying with dividing now. If, for example, we had something like simplify x squared y over xy, which again looks very complicated, but we can help ourselves by unsimplifying it first of all. We can help ourselves by writing it out in full. Think about this top line first of all, x squared y. Well, surely that could just be written as x times x from the x squared times a y. And on the bottom line, x times y. Why have I written it in that way? Think back to the simplifying powers stuff. With the simplifying powers, we wrote out the top line, we wrote out the bottom line, and we looked and said, well look, there's some stuff that's on the top and on the bottom. Here, I could put a box around x times y on the top and a box around x times y on the bottom. Note that we might not get these in the right order. This is a number. We don't know what that number is, but it is a number, and I am timesing it by the number in the orange box. How do I know that the thing in the orange box is a number secretly? Because x is a number, y is a number, so timesing them together gives me another number. There is a number in that orange box, and on the top line I am timesing by the number in that orange box. On the bottom line then, I am immediately afterwards dividing by the number in the orange box. The number in the orange box is having no overall contribution, so it might as well not be there. So I get rid of the stuff that's the same top and bottom, and in this case all I'm left with is x. Simplify e squared fg squared over efg, which is a mess. Yes, I agree. But we can do this one in exactly the same way. We can break these up into what they actually are. So on the top line, e squared is e times e, where e is a particular number. We don't know what it is. We're never going to know. Doesn't matter. Times that by an f, another number, and then a g and a g. We're breaking this apart on the top line. All of that is being divided by whatever this is on the bottom line, e times f times g. We can then look and see what we're left with. On the bottom, we are dividing by an e times an f times a g, and on the top, we are timesing by an e, an f, and a g. They happen to be next to each other here. It doesn't really matter if they're not. If we are timesing on the top by e times f times g and dividing on the bottom by e times f times g, they might as well not be there. We're looking for stuff that's the same top and bottom. All we are left with is stuff on the top, e and g. We are left with e times g, or rather e, g. Simplify 10x squared y squared over 2x. Well, again, we can do the same thing. We can break this up. So on the top, 10 times x from the x squared times y from the y squared. All of that gets divided by 2 times x on the bottom. We can then look at what is the same top and bottom. Not very much this time, to be honest. Well, let's deal with the x's first. So there's an x on the bottom and an x on the top. That means we are timesing by an x and then dividing by an x. That means they can go. The only other thing that we've got on the bottom there is a 2. Now, there isn't a 2 on the top, so we can't just get rid of it, except there kind of is. What have we got on the top? Well, not a 2, but we've got a 10 on the top and a 2 on the bottom. 10 divided by 2. Why divided by? Because that's what this line means. 10 divided by 2 is 5. So what we are left with is a 5 from the 10 divided by 2, and then the rest of the top line that we haven't crossed out. So that's 5 times the x here, times the y, or if we wanted to write that properly, we are simplifying after all, 5x y squared. The y times y gives us a y squared, and we can drop out the times signs, 5xy squared. So it is very much a case of look what's on the top, look what's on the bottom, get rid of anything that's on both, maybe do a little bit of dividing with the actual numbers that are there, write down what's left and make sure you've simplified that. So that covers us for the timesing and the dividing and the powers. The glaring omission then would be adding and subtracting. Now we can look at simplifying with adding and subtracting in one go. Adding and taking are very similar in that one is moving up the number line and one is moving down the number line. If we think, for example, about this particular expression, 5m plus 6m. Now, m is a particular number. Now, what we have here then, this is 5 lots of a number. We don't know what the number is, but it is 5 lots of that number. And this here is 6 lots of the same number. So it's 6 lots of a number, but the key thing is the numbers are the same. It is the same number. If we have 5 lots of a particular number and 6 lots of the same number, then surely what that gives us is 11 lots of the number. The number is m, of course. M is code for that particular number. So all we have is 11m. And 5m plus 6m would simplify to 11m. And what have we done? We've simply added together the numbers. 5 plus 6 is 11 lots overall. We can use that idea then to help us simplify with the adding and the taking. Because, for example, 3a plus 5a, well that's 3 lots of a number plus 5 lots of the same number. That would just be 3 plus 5 is 8 lots of the number. 10b take away 4b, we've not looked at a takeaway yet, but we could think about it in exactly the same way. We have 10 lots of a particular number, and then we're taking away 4 lots of that number. Well, surely that will just leave us with 6 lots of that number, 6b. And we could have multiple things going on at once. We could have, say, 13c plus 4c take away 6c. Well, that's 13 lots of a number plus an extra 4. So that's 13 plus 4 is 17 lots of the number. Take away 6 lots of that number. 17 lots, take away 6 lots would be 11 lots of that number, c. There is something to notice about these 3 examples, though, and the one that we looked at before with the m's. And that's the fact that the letters are the same within these things. Because it turns out that we can only simplify like this and combine things into one term where we're looking at the same information. Which kind of makes sense. 3 lots of 2 and another 5 lots of 2, say, would be 8 lots of 2. But 3 lots of 2 and 5 lots of 17 wouldn't be anything. It wouldn't be 8 lots of 2 or 17 or anything else. So we can only combine stuff in this way with the adding or taking where we are looking at the same information, the same letter, basically, the same code. That means that there are certain things that will not simplify anymore. Things that will not simplify past the point. I will give you 3 examples to give you an idea of the kind of things that won't simplify. Something like, say, u plus v. Just 2 completely different letters will not simplify. Because u is one particular number, v is another particular number. Without more information, without me telling you what u and v stand for, there is no way we can combine them together, u plus v, or in fact u minus v. But 2 different letters, even if we've got multiple lots of them, 2 different letters will not simplify anymore, and that's as simple as it will go. Something else that won't simplify, if we had, for example, 4x plus 1. Tempting as it would be to say this is 5 lots of x, it is not, because this is 4 lots of a particular number x, and this is just 1. Not 1 lot of x, not 1 apple or 1 pound, just 1. And that is not the same as having 5 lots of a particular number. It's 4 lots of a particular number, and then add 1 to it. So this will not simplify either. So if we've got something with a lettered term, a term? Hang on, what's a term? That's another word, surely. Yes, it is, and it's another word that I will use quite regularly. If we have equations or expressions here with the 2x plus 4, so the 2x, the plus 4, the 3y, and the plus 10 in these expressions and equations, each of these is a term. So a term is a bit of algebra within the bigger bit. So the 2x is a term with x in it, the plus 4 is a number term, the 3y is a term with y in it, and the plus 10 is a number term as well. So the term is a particular piece of an equation or expression. And something that's just a number on its own, then we are not going to be able to simplify anymore. Something else that will not simplify, something like this, say, x squared plus x, because they're 2 different things. This is a number times itself, and this is just the number on its own, and there is no way to actually simplify that. If you wanted proof of that, you could say, let's pretend that x is a particular number, and you can show that there is no way to simplify it to anything useful. There's no way to get from this to anything else. So these 3 types of things, these are just particular examples of those, but these 3 types of things will not simplify anymore. So that's if the letters are different, we can't simplify anymore. If we've got something with letters and something with numbers, they won't simplify anymore. Or in fact, if we've got things of different powers won't simplify anymore if we're adding or taking them. So sometimes with simplifying, it might not be a case of simplifying down to one single term. It might be that we just simplify as much as we can and get it as simple as possible, and then we have to stop. But we can collect together anything that's the same type of thing. Let's have a look at an example and see how this might work. And we'll jump straight in with a reasonably complicated looking question. And this question goes simplify and then a load of different bits of algebra. 4x plus 5 plus 9x take 4 plus x plus 12. And there's quite a lot going on there. You can see why we might want to simplify this, because there's a lot of stuff there. But if we look closely, we'll see that some of them are things with x's in them, and some of them are just numbers on their own. So surely we could collect these together and get down to a point where we've just got a total number of all the x's and a total number of just the numbers. Imagine a room and there are lots of different piles of pound coins scattered about in the room and lots of different piles of dollars scattered about in the room. Well, we could collect all that money up and we could collect all the different pounds together, the amounts of pounds, and we could collect all the different amounts of dollars together and then have a certain number of pounds and a certain number of dollars. We wouldn't be able to collect those anymore, but we could go around the room picking up all the pounds and we could go around the room picking up all the dollars. The same is kind of true here. We can go through this question and pick up all the x's and collect all them together because they're one type of thing, one currency if you like. And we can go through the question and we can pick up all the numbers and collect them together because they're another type of thing, another currency if you like. The only thing we have to be careful about is these signs, because we have to make sure that the sign stays with the thing it belongs to. So what we're going to do with these questions is the very first thing we're going to do is we're going to box off the numbers and the signs. So we're going to glue the signs to the numbers, and we're going to do this in a very particular way. We're going to start at the right hand side and we're going to box off one thing, one term and one sign. So one term and one sign, the 12 and the plus in front of it, and that plus is stuck to the 12. We're going to box off a term and a sign, so that's the x and the plus, a term and a sign, so the 4 and the minus in front of it, the 9x and the plus that's in front of it, the 5 and the plus in front of it, and the 4x there on its own. There isn't a sign in front of that 4x. If it was a minus 4x, it would clearly show as a sign. If we wanted to, we can put a sign in front of it. It doesn't actually matter in this case, but we could add that plus sign in there if we wanted. If the sign is clearly not a negative, you could put a plus in there to make it so that there is a sign in there. Why would I need to do this? Well, because now every term and sign are stuck together where they should be. This isn't just a 12 at the end, it's a plus 12. It's not just a 4 here, it's a minus 4. And what I can do is I can juggle these around now. I can move these around anywhere I want, because in moving them, I'm not just going to be moving the term, I'm also going to be moving the sign that belongs to it. So surely if when I move them, I could collect all the x's on one side of my page and all the numbers on the other side, all of one type over here and all of another type over here. So over here, let's collect the x's. Well, what have we got? We have got the 4x, the plus 4x really. And we have got the plus 9x. And we have got the plus x, which we might find helpful to write as a 1x if you want to put the number in. Letter on its own, remember, is just one lot of it. If you find it helpful to put that 1 in front of it, then you could put that there, but you don't have to. Now on the other side of the page, we could write down the numbers and their signs. So over here we've got the plus 5, and we have got the minus 4, and we have got the plus 12. So I've collected everything of one type on one side of the page and everything of the other type on the other side of the page, and I have kept the signs with them. It's why I've drawn the boxes around these in the first place. What I can now do is let's look at the x's first. Surely, because these are all the same type, I can just simplify these together and collect them into one single term. So if we look through these, we're going to have plus 4x's, plus 9x's, that's 13x's, or plus 13x's, plus the extra one, so plus 14x's. I'm going to keep that positive sign on there for now. And on the other side, 5, or plus 5, take away the 4 is plus 1, plus the 12 would be plus 13. Surely now I could just take the two things and combine them. So at this point I'm going to write the 14x's first of all. I can drop that positive sign off there because it is a plus 14. We wouldn't tend to bother putting plus signs on things. We'd only really show a sign if it was negative. So I'm just going to drop the plus sign off there. But this other one, I can actually write that next to it. I am going to keep the plus sign because it is a plus 13. And in collecting all these together, we've simplified it down to 14x plus 13. These two will not combine because this is a certain type of currency. This is like our pounds, say, and this is like our dollars. So 14x plus 13 is our simplified form. Let's have a look at another one. So again, another fairly complicated one, more complicated in fact, because this time we have got three things going on. Simplify 5x plus 2y minus 3 plus 2x minus 4y plus 1 plus y. Three different types of thing going on, three different currencies if you like. Some of these terms have x's in them, so we should be able to collect the x's together. Some of them have y's in them, so we should be able to collect the y's together. And some of them are just numbers on their own, so we should be able to collect those together. The x's, the y's and the numbers, however, will not combine with each other, because x's, y's and numbers on their own are just different types of thing. We could help ourselves with this, and we should do this every time. We're going to start at the right hand side. We're going to box off one term and the sign in front of it so that we are then gluing the sign to the particular term. We're not going to have any signs going missing or attaching themselves to the wrong thing or anything. So we're going to box off the y and the plus in front of it, the 1 and the plus, the 4y and the minus in front of it, that 2x and the plus there, the 3 and the minus, the 2y and the plus in front of it, and the 5x at the front, which we could make into a plus if we wanted to. Why is it a plus 5x? Because it's clearly not a minus 5x. Now we've done this, we can start to move these terms around, and we can switch the order around however we like. But we could make it so that we put all the x's together, all the y's together, all the numbers together. So over here on the left-hand side of my page, I'm going to put all the x's together. So over here we've got two terms that have got x's in them. We've got the plus 5x, and we have got the plus 2x. You could, if you wanted, even be ticking these off as you use them in the question, just to make sure we're hitting all of them. In the middle then, I'm going to write down the y terms, and there are three of these. We have got the plus 2y, we have got the minus 4y, and we have got the plus y, which if we wanted, we could put the 1 in front of to show that it is a 1y. We have then just got two terms left. They are the number terms, so I'm going to write these over here on the right-hand side of my page. That's the minus 3 and the plus 1. I've used all of my terms, and everything is now neatly arranged with the other things that are like it, with the other terms of similar currency, similar type, if you like. We can then start combining these. So over here, if we start with the x's, we are going to have plus 5x's plus 2x's. Plus 5x plus 2x is going to be plus 7x. Here in the middle then we can collect the y's. Plus 2y, take away 4y is minus 2y, and then plus that 1y will be just minus 1y or minus y. And over here with the number bit, we've got minus 3 plus 1 is minus 2. All I need to do then is I need to take these three things, combine them together and write them as my single final answer. So 7x, I can drop that plus sign because it doesn't really need to be there, but the other two symbols do need to be there, minus the y, minus the 2. Now the reason why I am encouraging writing that plus sign in there, even though it doesn't need to be there, is because what if you put these in a different order on the page? What if you put the number over here and the x's over here? Switch the position of the numbers and the x's. Well, actually, that doesn't matter. What you need in your final answer is you need these three things, the plus 7x, the minus y and the minus 2, in any order. So you could alternatively have written this as minus 2 minus y plus 7x, and that would be perfectly valid. We tend to go with the letters in alphabetical order still, so the x term first because that's the first alphabetically, then the y term because that's the second alphabetically, and then put the numbers on the end. But it is perfectly valid to write minus 2 minus y plus 7x. It will be perfectly valid to write minus y minus 2 plus 7x and switch them around in that way. It is perfectly valid to have these terms in any order you like as long as the signs are correct. As long as you've got a plus 7x, a minus y, a minus 2, nothing else, and no more combined than that. But the answer I've gone for, 7x minus y minus 2.